In my previous video, I mentioned the relationship between the empirical formula of a compound and its molecular formula. Let me quickly remind you. I used the example of glucose. And I told you that this formula for glucose is the molecular formula. Consider that the actual formula for glucose. The empirical formula for glucose, on the other hand, is this. The empirical formula is the simplest formula of a compound. How can we convert the empirical formula to the molecular formula? In the case of glucose, all we need to do is multiply all the subscripts in the empirical formula by 6. And that would give us the molecular formula. But the question is, how can we find this 6 after we have calculated the empirical formula? Let us call this subscript that we use to multiply everything, let us call it n. The formula for finding n is this. N is equal to the molar mass of the compound we're dealing with and this molar mass is usually given in the question. It is provided by the mass spectrometer machine. We divide that molar mass by the formula mass of the empirical formula. So after finding the empirical formula, we add up all the atomic masses of the elements in the empirical formula. Let us take a look at a question on this. Butane has an empirical formula of C2H5. So we know the empirical formula. Usually it will be calculated, but in this question, the empirical formula is just given out on a platter of gold. If its molar mass is given as 58.12 gram per mole, determine the molecular formula of butane. So we want to find the molecular formula. We know that to convert empirical formula to molecular formula, we will need to multiply the subscript of everything in the empirical formula by a factor n, and that will give us the molecular formula. Let us now find n. N will be equal to the given molar mass, which in this case is 58.12 gram per mole. So that will be 58.12 gram per mole divided by the formula mass of the empirical formula. The empirical formula is C2H5. Each carbon atom on the periodic table is 12.01, and that will be multiplied by 2 because we have C2. We will add that to 5 times 1.01, which will be multiplied by 5 because we have 5 hydrogen atoms in the empirical formula. And if you use your calculator to do this, you should get 29.07 gram per mole. So we will divide the molar mass supplied by the formula mass of the empirical formula. If you divide these two, you should get 1.999. Now, whenever we get n, in the case of n, we simply round to the nearest whole number. We do not multiply n by anything. So in this question, n is approximately 2, which means that the molecular formula for butane will be C2H5 multiplied by the factor n, which is 2. And that is going to give us C4H10. So that is the molecular formula. Let us now combine our knowledge of empirical formula and how to use that to calculate the molecular formula. In this question, we have a carcinogen named benzoapyrene with a molecular weight of 252.30 gram per mole. From the unit, we know that that is the molar mass of benzoapyrene, is found to contain 95.21% carbon and 4.79% hydrogen. Those are the percentages you see on the screen right now. This is the question. What is its molecular formula? We know that to find the molecular formula, we first need to find the empirical formula. And to find the empirical formula requires 3 steps. If we assume 100 grams of the sample, then 95.21% of carbon will become 95.21 grams. And 4.79% of hydrogen will become 4.79 grams. We have completed the first step. The second step is to convert the masses to moles. We know that for carbon, 1 mole of carbon atom will have a mass of 12.01 grams from the periodic table, and 1 mole of hydrogen will have a mass of 1.01 grams from the periodic table. If you divide 95.21 grams by 12.01 grams to get the mole, you should get 7.92756 mole. And if you divide 4.79 by 1.01, you should get 4.74257 mole. We have successfully completed the second step. To find the third step, we need to divide both moles by the smallest or the smaller between them. The smaller one is 4.74257 mole. We divide both of them by that. This gives us 1, and the mole ratio for carbon is 1.67157. Now remember, we do not just round the mole ratios to the nearest whole number. In this case, we have something that looks like 1.7. And if you remember how we treat the mole ratios, anything that has 0.7 must be multiplied by 3. But whatever you do to one, you must do to the other mole ratios. So we will now get 5.1 and 3 as the mole ratios. 5.1 is approximately 5 and 3 is still 3. So the empirical formula for benzoapyrene will be C5H3. Let us now use the empirical formula to find the molecular formula. We know that to do that, we need a factor N. The molar mass of the benzoapyrene is given to us as 252.30 gram per mole. The formula mass of the empirical formula can easily be calculated. That will be 5 times 12.01 for carbon and 3 times 1.01 for hydrogen. Remember, these two numbers are obtained from the periodic table. That should give us 63.08 gram per mole. So N should be equal to 252.30 gram per mole divided by 63.08 gram per mole. If you divide, you should get N to be 3.9996, which should be approximately 4. Remember, we only simply round N. That means the molecular formula for benzoapyrene will be equal to C5H3 multiplied by the factor N, which is 4, which means that the molecular formula will be C20H12. I now need you to try to do this one by yourself. If you do it correctly, you should get C13, H18, O2 as the empirical formula for ibuprofen. And when you calculate the N factor, your N factor should be 1, which means that the molecular formula should also be C13, H18, O2. They are the same for this compound, and in many situations the empirical formula can be exactly the same as the molecular formula. For example, H2O, the empirical formula is exactly the same as the molecular formula, and many others. In such situations, your N factor will be equal to 1, but they will not be the same if N is not equal to 1.